In our next section, we're going to look at running the EasyVPN server on the ASA. And the first thing we're going to start with here is to look at some of the similarities between the ASA's VPN server and iOS, and then some of the differences, and finally how to do the actual configuration. Now, when we compare the two of them together, the ASA as the VPN server and iOS as the VPN server, the ASA tunnel group is what is going to be synonymous to the iOS ISACamp profile. We previously saw that with the ISACamp profile on iOS, we were able to offer different types of authentication, different types of access lists, or different types of address pools, depending on the particular group and username credentials that the individual VPN client is offering. So on the ASA, we could have one physical interface that's connecting to the outside network, but then based on how the users authenticate to different tunnel groups, we can offer them different types of services, whether this be restrictions on bandwidth or restrictions on what particular resources they can access internal to the network. The other portion we have is the group policy on the ASA, which is going to be synonymous to the iOS's client configuration group. This is where we would specify things like the split tunneling policy and other variations of different VPN options, like what's the banner that the user is going to see when they log in, what's their DNS server, what's their Win server, etc. Now, one key difference between them that the iOS supports and the ASA does not is that there are no virtual tunnel interfaces, or there are no VTIs. We'll see configuration-wise, the ASA's EasyVPN server is similar to the legacy version of the iOS EasyVPN server, where we are using both static and dynamic crypto maps in order to receive the Phase 1 and the Phase 2 negotiation on the interface, and then associate those with the tunnel groups and with the group policies. Now, another key point to know about the ASA's VPN server is that the default values for the tunnel groups and the group policies are going to be inherited from two different configurations: the default remote access group for the tunnel and the default group policy. Now, we'll see when we're actually going through this configuration, one thing that can help us piece this syntax together is to look at the show run all tunnel group, which is going to show us the default options for the default RA group, which is for our remote access, and the show run all group policy, which is going to show us the default group policy, which is then going to control things like the split tunneling policy and the different options that we want to offer in Phase 1.5 down to the VPN client. Now, again, the normal Phase 2 configuration is still going to be implemented using crypto maps, which is going to use both the dynamic and the static configuration. In our particular topology here, we're going to be setting up ASA2 as the VPN server, where the goal is that when the clients come in, we want them to have encrypted access to the 10 network behind the ASA. Now, whether this were to be the software client on the test PC, or whether this were to be the iOS's VPN client, we could configure this on router 3 to be the VPN client. It's going to be the same configuration for the server and the same behavior of the client. Now, just like in the iOS, there are a number of different commands we need to use in order to get this configuration functional. So this is definitely one of those things where you want to know where is it located in the documentation, and what are some of the shortcuts that I can use on the command line itself in order to piece this configuration together. So first, let's look at this on the documentation, and then we'll look at the command line of the ASA and look at the show run all command and also the VPN setup command that's going to give us some of the syntax help in order to piece the configuration together. So from our main documentation page, we're going to go down to Products, to Security, then to Firewall, Appliances, ASA 5500, Configuration Guides, and then finally to our version, which in this case is 8.1. Then under Configuring VPN, we have configuring the tunnel groups, group policies, and the users, and then configuring remote access VPNs. Where this portion here, configuring remote access VPNs, this is going to show us what we need to do for our basic crypto map configuration, for the basic ISACAMP policy configuration. Then the real specifics of the per user attributes, that's going to be under the tunnel group, group policy, and the users section. Now, one thing that's nice about this document, just like the LAN-to-LAN VPNs, is that the first portion shows us an overall summary of the individual commands we need to issue in order to get the most basic functional configuration. Now, if we look at some of the syntax that they have here, we can see that the first portion of configuration is the same as just a normal LAN-to-LAN tunnel, where we have our phase 1 parameters defined by the ISACAMP policy. We have our encryption. We have the hash algorithm, whether this is SHA or MD5. We have the Diffie-Hellman group. We have the phase 1 ISACAMP SA lifetime. Then we have the authentication. Now, just like in iOS, if we're doing pre-shared authentication for phase 1, it means that the username is going to be the group username, and the password is going to be the pre-shared key for that individual group. Where in the case of the ASA, this is what is the tunnel group name. Where they're saying test group here is an IPsec remote access tunnel group. It means that when we go to the Windows VPN client, or if we were to go to the iOS VPN client, the group username is going to be test group. Then we see we have the IPsec attributes for that group where we're specifying the pre-shared key. Then under the group policy, we're going to have the rest of our phase 1.5 parameters. Now, we'll see here that they're really not changing anything that is related to the group policy. So we're going to look at the show run all on the command line and see what are the other options that we would need to change in order to implement things like split tunneling on the VPN server. So let's start with this configuration here, and we're going to then change this around in order to meet our individual requirements. So let's paste this into Notepad. And one thing I don't believe I showed before is one of the shortcuts you can do in the exam. If you're editing in Notepad, and you can see I need to remove some of this output before I actually put it into the command line, you can use just the basic find and replace feature. If I were to say replace hostname, config, #, just replace this with nothing, then replace all, it's going to delete whatever was at the beginning of those lines. So it's a quick way I can just parse through this text and then get it a little bit closer to the format that I need for actually putting it into the command line. Then the rest of this we could just quickly delete what we don't need. Okay, so if we start at the top, we know we don't need the interface configuration. That's already ideally going to be configured on the ASA. First step would then be our ISACAMP policy. Just like for the LAN tunnels, we're going to start at the lowest numbered policy, which in this case is number 1, and we're going to work down from there, just like an access list or a route map, where as soon as the first match occurs, we're then going to use that policy and not look at any of the other ones. So if I wanted to support multiple VPN clients, where maybe some of them support more secure phase 1 negotiation, like using AES and SHA and group number 5 and certificates, then ideally I would want to put that towards the top of the policy, and then the less specific or the less secure ones down towards the bottom. Now, in this case, we don't really have any specific requirements that we're trying to meet, so we'll just use the policy that they have defined. Next, we have ISACAMP enabled on the outside interface, where again, different from the iOS. For iOS, as soon as you apply the crypto map on the interface, it's automatically going to start listening for ISACAMP. In the case of the ASA, you do need to manually enable this on the interface that you want to listen for the tunnel to come in. Now we start to get into our phase 1.5 parameters. In mode configuration, we're then going to be assigning the users an address. In this case, they're saying 192.168.0 with 6 possible hosts, the .10 to the .15. Then, obviously, if I want to support more than 6 VPN clients, I would need to increase the address space. So I could say .1 through .254. Now, just like with the iOS design for the VPN server, once the client authenticates and they're assigned the address, I need to make sure that the other portions of the network actually have a route back to this pool. So this then means I would either need to do reverse route injection on the server, or we need to do some sort of static routing that is going to tell the internal hosts on the inside of the ASA how do I actually get back to the 192.168.0/24 network. So once we actually have the clients connecting, then we'll look at the different variations of the routing. I then have my username and password combination for extended authentication. So for simplicity here, I'll just say the username is Cisco, password is Cisco. And then I have the phase 2 transform set for the IPsec SA. Says the transform set is first set, which is going to be ESP triple DES and ESP MD5, which is fine. Then we have the tunnel group. They're saying the name is test group, where it's an IPsec remote access group. The address pool is test pool, which we're defining here. The IPsec attributes include the pre-shared key for the group username, where here the group username is test group. So for simplicity, I'll just say this is Cisco. So now once we have the phase 1 and the phase 2 parameters, and then we need to tie all of this together with the crypto map. We have the dynamic map that says I'm going to use this particular transform. I'm also going to set a reverse route back to the client, which is going to be an address from this pool. Then the dynamic map, which is named DYN1, is then called from a static map, which is my map. And then the static map is applied to the interface. So overall, you can see the configuration is not too complicated. When we get into some more of the advanced examples, changing the attributes of the tunnel group and of the group policy, then it's going to be definitely helpful to look at the show run all on the ASA's command line. So now let's take a look at the command line on the ASA, and specifically this is going to be ASA 2. And if we look at the show run all tunnel dash group and the show run all group dash policy, we can see what are the defaults going to be for the phase 1.5 negotiation. If we look at the first portion, which was the tunnel group, we have the default remote access group, which is what is going to be used for the VPN client. It says that by default we have no address pool assigned, no IPv6 address pool. We're going to use local authentication for the username and passwords. And we're going to be using the group policy called default group policy. Now, if we were to change any of these options, let's say, for example, we wanted to give them an address pool, we could do this either by editing the default remote access group, or we could edit the individual tunnel group that we are associating with those users. Because the key point is that the defaults are going to be inherited from the tunnel group and from the group policy that we define. Where notice here in their example, under the tunnel group test group, basically the only thing they're specifying is what is the address pool and what is the pre-shared key. They're not specifying that we are using a different authentication server group. So if I wanted everyone to go to Radius or everyone to go to TACX by default, I could change this default remote access group and then specify those individual options. Or if I want to say that for the usernames from the certificates, if I were to do certificate authority support, I could say maybe don't use the organizational unit, just use the common name. Then that would apply to everyone that is a remote access user, unless I have a more specific policy in an individual tunnel group that overrides those options. Now, if we look down towards the second portion, which is the group policy, this is where the vast majority of our phase 1.5 parameters are going to come from. Like the VPN filter, this would be an access list that is applied to the tunnel itself. So if I wanted to say that when the user authenticates, I want them to be able to use port 80 over the tunnel, but nothing else, which is different than the split tunneling policy, which controls basically the proxy ACL or the proxy identities, which means what traffic from the client's perspective goes over the tunnel versus over their regular clear text interface. Now, for this configuration, the only thing that I'm going to change from the example that they're giving in the documentation is simply to set the split tunneling policy, because when I connect from the test PC, I want to make sure that my remote desktop connection that's actually going to the GUI interface, I want to make sure I can get access to this as opposed to sending all of the traffic over the tunnel. Now, if you see that you are connected to the test PC or you are connected to, let's say, the ACS server, and you connect them to the VPN servers, and your access to the GUI interface drops off, it most likely means that your split tunneling policy is wrong, and that the Windows machine is actually dropping the remote desktop packets coming in. So next, let's try this out. Let's take our configuration and enter this onto the ASA, where we did get one error message. It says the transform set with the tag first set does not exist. So it looks like there's some sort of syntax error with their example here. And most likely there's probably a dash between transform and set instead of a space. So let's try crypto IPsec transform dash set. Then let's reapply the rest of this config to make sure nothing else dropped out as well. Next, we're going to look at the debug crypto ISACamp and turn logging on. We'll say logging to the console at level 7 and logging is on. So now if we were to go to the VPN client, the Windows machine, what we should see ideally is that once the connection is active, we should be able to send traffic to someone that is behind that protected network. So let's say this LAN segment of router 6, which is 10.0.6.6/24. So from the client, I'm going to ping 10.0.6.6, and we'll continue this this traffic to go on. Now we see at this point I do not have reachability to that host, and the reason why is that ASA2 is going to be dropping this traffic as it comes in on the outside interface. So it's normal clear text ICMP right now, and the ASA is not going to allow that from the lower security interface, which is the outside, to the higher security interface, which is the inside. If we look at the ASA, we can see from the logs it says we're denying the ICMP traffic that's coming from the Windows machine trying to go to router 6. But at a minimum, what this is telling me is that there's no underlying routing problem in the network from the test PC at least getting to the outside interface of the ASA. So I have basic transport to start. So now let's try connecting the VPN tunnel. We'll go to the client, create a new connection. We'll say this is ASA2 with an address of 200.0.122.12. That's the outside address of the ASA. The group authentication name and password is then going to be what the tunnel group name is and what the pre-shared key for the tunnel group is. Where in this case, this is test group. And then the password is Cisco. Now remember, just like the iOS as the VPN server, if I double click on the entry and I get this username and password box to appear, this means that the phase 1 negotiation was successful. If we were to go to the ASA and look at the show crypto ISACamp SA, it says that we are in aggressive mode and we are initiating the extended authentication. So right now we're looking for the individual username and password authentication in order to then assign them the additional attributes, which in this case the username should be Cisco, password is Cisco. That's what I had globally. Now once the client is connected, if we look at the debug output from the ASA, we see that during the rest of phase 1 of negotiation, it says that I have the group name test group, the username Cisco for this specific IP address. Then we'll see the rest of the attributes that it is applying onto them. If we turn logging off, let's say no logging console, and then look through some of the details of this log, we should see that first off, the packet comes in and it lands on the test group. So we see we have the ISACAN packet coming in from the VPN client. It then says the connection landed on the tunnel group named test group. So this means now at a minimum the client has the correct tunnel group configured, as does the server. Now we should see them going through the individual negotiation, where we're going to negotiate our phase 1 ISACAN policy. We then go to the extended authentication. It says username is Cisco. The authentication is correct. Then we get down to actually assigning them the attributes that we defined during phase 1.5. So we can see there's no banner that we have configured. There's no DNS server. They're asking us now for the address for the net mask for that particular address, and we should see the individual assignments, where it says the client was now assigned the IP address 192.168.0.1 from the local pool, and any of the other options that we're defining. Okay, again, when we look at the show run tunnel group, the only thing that really was defined in their example was just the address pool and the pre-shared key. If we look at the show run group policy, we do not have any non-default group policy configurations. So this essentially means that that user, once they authenticate, they're going to get all of those attributes that match the show run all group policy and match up with the default group policy. So not only does this mean that there's no banner assigned, that there's no DNS server, that there's no restriction on what the time of the day they can use the connection, but some of the important ones here would be that IPsec over UDP is disabled, which means that the VPN server is not going to offer transparent tunneling, and that the split tunnel policy says you will send all traffic over the tunnel and that you will not do any split tunneling. So now if we were to go to the client, we would actually see that the remote desktop connection times out, because now the Windows machine is dropping my traffic that is coming in on its inside interface, because the routes are now pointing all out the VPN adapter. So this is the first change that I'm going to make, that I'm going to change the split tunneling policy so that we're going to specify an access list that says traffic going to the 10 network is what's going to go over the tunnel, not everything. Now again, just like on the iOS's VPN server configuration, the access list is going to be from the perspective of the server, not from the client. If I specify access list 100, permit IP, it means that the 10 network is going to be the source of the packets, not the destination. So from ASA2's perspective, traffic is coming from the 10 network going anywhere, or more specifically, I could say going to that individual pool. But we'll say for traffic going anywhere, this is going to be our split tunneling ACL. Now, to actually apply this, I have two separate configuration options. I could change the defaults for the default group policy, or I could define a new group policy and then apply it to that individual test group. Again, the difference between these two is that if I have multiple tunnels at the same time, and if I were to change the default group policy, then multiple tunnel groups would inherit the changes that I'm making to the default group policy. So it really just depends on the hierarchy of configuration that you want to use. In this case, I'm going to define a new policy. We'll say group policy, give it a name. I'll say VPN client policy 1. And this is an internal policy, which means that I'm not getting the policy from the TACX server. The individual attributes that the policy has that specifically I want to change is what is the split tunnel policy and what is the split tunnel list. Where the split tunnel policy says, can you do split tunneling, yes or no? So I want to tunnel what is specified. It means that the access list I'm going to call is going to say what traffic you want to go over the tunnel. The other option would be to say exclude specified, which would say that for whatever is matched in the access list, that is the traffic that is not going over the tunnel. So it depends on how you want the logic to work. Do you want to match it in the ACL and say that's what should go over the tunnel, or match it in the ACL and then say that's what should not go over the tunnel? Then I need to specify what is the actual access list name or number, which is the split tunnel network list. We'll say the value for this is 100, which is the access list's name. Now, if we look at the show run group policy, we see those two new attributes are defined. Then under the tunnel group, when we show run a tunnel group, I now need to actually call the VPN client policy 1 from the tunnel group test group. So we'll say the general attributes which is going to be the default group policy. So I'm going to use now the new policy that is VPN client policy 1. If we look at the show crypto IPsec SA and the show crypto ISACamp SA, we see that the tunnel is currently connected to the VPN client. They've been allocated this address. If I clear crypto SA or clear crypto IPsec SA and clear crypto ISACamp SA, now it should disconnect the client. If we go back to the remote desktop connection, we should see that we're able to reconnect to the client. So let's try this again. Let's reconnect to the ASA. Username and password box shows up again, which means that the phase 1 negotiation was successful and it's completed. Once I enter the password, now I should go into phase 1.5, then ultimately get the phase 2 parameters, which are going to be like the encryption algorithm and the hashing algorithm. We go under the status and look at the statistics. It says the transform set I received was triple DES and MD5. My client's address is 192.168.0.100. Transparent tunneling is inactive. This means that the packets are not getting encapsulated inside UDP or TCP, but instead are natively going to be sent as ESP packets. We also see that nothing is getting encrypted or decrypted. So let's go back to the Windows command line and we'll reinitiate these pings where I'm trying to get to router 6. Ideally, I should see packets going out the tunnel and then coming back in the tunnel. We can see some traffic is getting encrypted, but nothing is getting decrypted. If we look at the routing details, we should see the split tunneling access list was learned. And if we go to the Windows command line and look at the route print, we should likewise see it here. that it says now to get to the 10 network, go to 192.168.0.2, which is the other end of the VPN tunnel. Now, if we continue to send these packets, ideally what we should be able to do is to go to the recipient, which is router 6. If we go to 6 and look at the debug IP ICMP, I want to see that traffic is coming in from the address that the ASA has allocated, which again is, if we go to the details here, it's the 192.168.0.1. On router 6, we're going to look at the debug IP ICMP. And we can see that the packets are getting to router 6, and the source that they came from is 192.168.0.1, which is what we are trying to reply back to. So this is now telling me that the traffic is coming in the tunnel and getting routed down to router 6. Now, as to exactly why the traffic is not getting back, there could be a couple different issues in the design that we need to take into account. One of them would be once the packets actually get to router 6, does 6 know how to send them back? So do we have a route to the tunnel endpoint that the ASA is allocating from its internal address pool? The other issue would be, since ASA2 is not offering transparent tunneling over UDP or transparent tunneling over TCP, can the VPN client get the ESP packets to the VPN server, and can the VPN server get the ESP packets back? So first, let's go to router 6 and see if there's any issue with the routing control plane. So does router 6 actually know how to get to 192.168.0.1? Which it does not. If we look at the routing table, I want to know, maybe do I have a default route that I can use in place of this, which I do not. So I now need to figure out how can I get the ASA to advertise this address space down to the rest of the routers. Now I could simply go to router 6 and say to get to 192.168.0.0/24, use router 5, and then on router 5 statically point that to the ASA. The problem is that that's not very scalable or manageable, and within the scope of the CCIE lab exam, you may not be able to do that. So we know static routing is one option, but let's look at the other configurations, which mainly is going to be the reverse route injection on the ASA. Now, based on their configuration example, when we look at the show run crypto map, they already did say for the dynamic crypto map that the reverse routing is set. What this means is that once the client authenticates and they successfully complete phase 1, 1.5, and phase 2, we're going to install a static route in the routing table pointing towards the interface that the tunnel came in on, which in this case, this is the outside interface. So the ASA has a route back to the client, but router 5 and router 6, they do not. And the reason why on the ASA, if we look at the show run router, under the dynamic routing domain, which in this case is EdgeRP, I am not redistributing these static routes to the rest of the EdgeRP network. So this would be one option. I could go under EdgeRP and say redistribute static, which is then going to include this address. I could also remove the set reverse route and simply put a static route for the entire pool, where I could say to get to, on the outside interface, to get to 192.168.0.0/24, send the packets towards router 2, which is 200.0.122.2. Then under EdgeRP, I'll simply say redistribute static. I need to give it a metric. Then additionally, I could do filtering here if I wanted to control what particular static routes are redistributed into EdgeRP. So here, this isn't directly related to the IPsec tunnel per se. It's a separate routing control plane issue that we need to solve, regardless of whether we're doing a LAN-to-LAN tunnel, whether we're doing remote access tunnels, or just normal packets that are transiting the routed domain. So we can't send packets to the destination unless we have routing information for it. If we now go to router 6, look at the show IP route, we now have the exact /32 route that the ASA is injecting into its routing table based on the reverse route injection. Now, if I were to remove that entry from the crypto map, let's say we're not going to do reverse route injection, then on the VPN client, I'm going to disconnect and reconnect. What we would see now, if we look at the show route outside, and I may need to clear the routing table here, but let's say show crypto ISACamp SA and show crypto IPsec SA. So I have the tunnel that's up to the client. The client has been allocated, again, 192.168.0.1. If we look at the show run crypto, the dynamic crypto map is no longer setting the reverse route injection, but the ASA does still have this static route assigned. So what I may need to do here, let's say clear crypto IPsec SA, clear crypto ISACamp SA, and clear route outside. What I should instead see is just see the single static route that I manually configured, which is for the entire pool. If I were to now look at router 6 and look at the routing entry for that individual host, now it goes to the /24 match, not the particular /32 that was from the reverse route injection. Now again, just like the iOS VPN server configuration, the only time this is really going to make a difference when you're advertising the host route versus the full network is if you have multiple VPN servers on the edge that are both using the same pool to allocate for clients. So if ASA2 has the client .1 connected, but ASA3 has the client .2 connected, I would need to know, am I supposed to send this traffic to ASA2 or to ASA3? Which is what the host route is going to take care of for us. But in the current design, since there's only one possible VPN server, there's really no need for router 5 and router 6 to have the individual host routes to all of the clients that are connecting. And that's what sometimes is called as the hold down route. It's basically a manual placeholder, the static route for the entire address pool that we are then automatically advertising into the routing domain, which again I did with the redistribute static into EIGRP. So now if I go ahead and reconnect the VPN client, then on the ASA, look at the show route outside. We have the individual host route plus the hold down route. So what I may need to do if I wanted to remove this entry, I could delete the crypto map from the interface and then reapply it. I possibly would have to reload in order to get this to come into effect. But the ultimate result would be that we're having the single hold down route and not the individual host routes. So now in router 6, if we look at the routing entry, we should see that this is going to change from the /24 back to the /32 because we're doing static redistribution on the ASA. So regardless, whichever way that you solve this, just take that into account that the routing is separate than the IPsec process. If we don't have a route back to where the tunnel is coming from, then we're not going to be able to establish the tunnel. If we don't have a route back to the tunnel address itself, So what the VPN server is allocating, then we can't send traffic back to the client. Okay, so this is one issue. Now if we look on router 6 and debug IP ICMP again, we should see the packets coming in from 192.168.0.1, and ideally these would be successful, which they're not. Again, if we look at the statistics of the client, it says the packets are going out the tunnel, but they're not coming back in. They're being encrypted, but they're not being decrypted. So next, let's compare this with the ASA. If we were to go to ASA 2 and look at the Show Crypto IPsec SA, it says that packets are getting both encapsulated and decapsulated. They're getting both encrypted and decrypted, and the authentication is successful. So in other words, if we were to look at the diagram, it means that the packets are going from the test PC to router 6. 6 is replying. They get to the ASA is sending them out. But somewhere from this link to this link, the packets are getting dropped. Where in this particular topology, we know that we're going through ASA 1, but maybe we have some other sort of filtering, like a static access list or the CBAC feature set or zone-based policy firewall on the iOS in the transit path. So we do need to take into account, just like the iOS VPN server, how are the packets getting encapsulated in the tunnel? So are they using their normal tunneling protocol of ESP, or are they being transparently tunneled over UDP or TCP? So the same type of options we saw on the iOS server, we can do those on the ASA. We could force the packets to go into UDP encapsulation with NAT traversal or NAT transparency, or we could do the manual transparent tunneling over UDP port 10,000. The same would be true of TCP. So these last two options, these are the Cisco specific ones. Where NAT traversal is RFC defined, the UDP and the TCP encapsulation, those are specific to the ASA and to the iOS VPN server. Now to do the NAT traversal, the only thing we would need to do would be to go to the ASA and then configure NAT. So if we were to go to ASA 1, and under this particular context, which is switch 2's vThen 118, I could say I want to do a NAT rule for traffic coming in on the inside interface. This is NAT rule number 1, and I'm just going to translate everything. The global pool on the outside is going to be whatever the interface's address is. So we're simply doing port address translation. If we now go back to the client and disconnect, then reconnect, we see that transparent tunneling is now active on UDP port 4500. So since we're going through a network address translation, it means that the ASA is automatically offering us that particular port value. And we can see now the packets are getting through because there's no one in the transit path that's doing filtering of UDP port 4500. If we go to the ASA and look at the ASA who's the server, and we look at the show run all ISACAMP, this option here, Crypto ISACAMP NAT Traversal, this is on automatically. If I were to disable this and say no Crypto ISACAMP NAT Traversal, it means that when the client connects, the ASA is not going to offer them this option of transparent tunneling over UDP port 4500. Where normally you would want to do this, you would want to offer them transparent tunneling because the vast majority of the time your VPN clients are going to be going through a network address translation. But we can see now the difference here says transparent tunneling is inactive because I disabled that feature on the server. The other option then would be to go to the client, or excuse me, the server, which is ASA2. And if we look at the show run all group dash policy, we could tell them to allow IPsec over UDP using this specific port number. So again, this option is different than NAT traversal or NAT transparency because you can use it in cases where you are not going through a network address translation. UDP port 4500 is going to assume that the client is behind a network address translation. Then the server is going to figure that out based on a disconnect of where the ISACAMP packet comes from and the IKE identity, which is their pre-network address translation address. So now if we look at the show run group policy, I'm going to say that for this particular group policy and in the attributes, I'm going to say that IPsec over UDP is enabled. If we now disconnect and reconnect the client, we see now transparent tunneling is enabled, but the difference is that it's running over UDP port 10,000, not NAT transparency or NAT traversal with UDP port 4500. So again, regardless of whether we are using the iOS router as the EasyVPN server or the ASA as the EasyVPN server, you still need to take into account how the traffic is encapsulated. So is it the ESP, UDP, or TCP? And then how does the routing work back to the client? So am I doing reverse route injection? And is this automatically getting redistributed to my routing protocols? Or do I have some sort of static hold down route that is telling the inside host how they get back to the pool that the VPN client is using? Now, we'll see in some later options when we get into more advanced examples of this and integrate the EasyVPN server with Radius and with TACACS. When we look at the show run all group policy, there will be matching options on the ACS server for each of these individual attributes that are defined in the group policy, where we could configure a specific authentication group inside Radius that says for the users in the sales group, when they come in, I'm going to give them an access list that's going to allow them to get to their specific servers, but it's different than someone who is an administrator of the network that is allowing them to telnet to all the internal devices, or maybe to run SNMP to the internal routers and switches. But for each of these options, when we get to the ACS server, we'll see that we can apply this on a per user basis, and we can apply this on a per group basis. Then in order to do this, I would need to make sure that from my tunnel group, when we show run all tunnel dash group, when the users come in, I would want to set the authentication server group. This would either go to Radius or TACACS as opposed to going to the local database, and then the same would be true of accounting. So if I want to do Radius accounting to see when the users connect and disconnect and exactly what they do, and then we could do that separately from the authentication. Now, lastly, the other way that we could use syntax help for this configuration, if we were to go to global config and look at the VPN setup for IPsec remote access steps, you'll see this output is similar to what was in the documentation, where they're showing the individual portions you need to do to configure this. With this example, though, they are using Radius as opposed to using the local database. So they're specifying we're using Radius. This is the server. This is the server's encryption key. Then under the tunnel group, which they're naming client, they're saying use the Radius group called my Radius, which is defined there. The rest of this is pretty similar to what we saw in the documentation example, where we have the dynamic crypto map, which is then called from the static crypto map, The static crypto map is applied on the interface, and ISACAMP is enabled on the interface as well. The rest of the tunnel negotiation, or the debugs or the show outputs, are going to be identical to what we previously saw with the LAN-to-LAN tunnels on the ASA. So we would look at the show crypto ISACAMP SA. So is the phase 1 tunnel up? If we look at then the show crypto IPsec SA, I want to know, are packets actually getting encapsulated? Are they getting decapsulated? Do I have the correct address assigned to them? Do I have the correct transform set? Am I using UDP encapsulation or not? Then if we have some problem in this, we can look at either the debug crypto ISACAMP or the debug crypto IPsec.